SpaceX's 2025 started with a bang, literally. After an impressive streak of successful launches in January, including a milestone Starship flight, the space community was buzzing with optimism. This is the year SpaceX reaches new heights, experts claimed. Fast forward just 3 months, and that narrative has dramatically shifted. The company that seemed unstoppable is now facing a sobering reality check. Critical failures are mounting, deadlines are slipping, and their flagship Starship program is struggling to maintain momentum. While fans and investors focused on the spectacular potential of Mars colonization, serious problems have been developing behind the scenes with their workhorse, the Falcon 9 rocket. On March 2nd, disaster struck when a routine Falcon 9 mission encountered a catastrophic fuel leak. Though the booster initially landed successfully on the drone ship, within 35 seconds, leaked kerosene ignited, engulfing the rocket in flames before it toppled overboard. This wasn't just an isolated incident. Just a month earlier, another Falcon 9 upper stage failed to properly deorbit, resulting in debris scattered across a field in Poland. The question on everyone's mind, is SpaceX pushing its launch frequency beyond sustainable limits? With 26 Falcon 9 launches completed by early March 2025 and plans for an unprecedented 180 launches this year, the company is attempting something never done before, launching a rocket every 2 days. Has Elon Musk's obsession with Starship diverted critical resources away from their reliable moneymaker? Are we witnessing the consequences of ambition outpacing engineering reality? Welcome to Elon Musk 24 Hours. Let's dive right in. To truly understand what's happening at SpaceX, we need to look beyond the dazzling Starship explosions that dominate headlines and focus on the backbone of their entire operation, the Falcon 9. For years, this rocket has been the most reliable launch vehicle in history. With its revolutionary, reusable first stage, Falcon 9 transformed the economics of spaceflight. Industry experts called it the Model T of rockets, the vehicle that made space truly accessible. By 2025, some boosters had flown over 15 missions each, an achievement that would have seemed impossible just a decade ago. But success breeds ambition, and ambition can push systems to their breaking point. Let's examine what happened on March 2nd more closely. During liftoff, engineers detected a fuel leak in the booster. Kerosene sprayed onto a hot section of the engine, a potentially catastrophic situation. The only reason it didn't immediately explode was the lack of oxygen at high altitude. But danger was only delayed, not averted. After the booster touched down on the drone ship, seemingly another routine landing, disaster struck. Within 35 seconds, the leaked fuel found enough oxygen to ignite. Cameras captured the horrifying moment as flames erupted from the engine bay, rapidly consuming the landing legs and structural panels. The $30 million booster then lost stability and tumbled into the Atlantic Ocean. A SpaceX engineer who requested anonymity told us, "These vehicles are designed with multiple redundancies, but when you're pushing them to fly every few weeks instead of every few months, microscopic stress fractures and wear patterns can develop in ways our models don't always predict." What makes these failures particularly concerning is the sophisticated nature of Falcon 9's landing sequence, arguably the most complex part of its operation. Unlike traditional rockets discarded after a single use, Falcon 9 must perform an intricate ballet to return safely to Earth. This sequence begins approximately 2.5 minutes after launch when the first and second stages separate. While the second stage continues to orbit, the first stage begins its journey home. For missions requiring maximum fuel efficiency, the booster targets one of SpaceX's autonomous drone ships positioned hundreds of miles offshore. These floating platforms with names like "Of Course I Still Love You" and "A Shortfall of Gravitas" use powerful thrusters to maintain position despite ocean currents and weather conditions. As the booster descends from the edge of space at nearly 5,000 miles per hour, it fires a subset of its 9 Merlin engines in what's called the entry burn. This slows the vehicle and shields it from atmospheric heating that would otherwise tear it apart. The booster deploys 4 titanium grid fins that adjust its trajectory with microscopic precision, essentially flying the rocket back to its target. In the final moments, the landing burn brings the booster's speed from 250 miles per hour to zero in just seconds, while simultaneously extending 4 landing legs. The margin for error? Less than 1.5 meters on a platform that's itself moving with the ocean swells. When you understand this complexity, it becomes clear why pushing launch frequency comes with exponential risk. The March 2nd failure wasn't an isolated incident. Just 1 month earlier, on February 1st, another serious anomaly occurred. After successfully deploying its payload, a Falcon 9 upper stage suffered a liquid oxygen leak that froze its thrust vector control system. Unable to maintain proper orientation, the stage re-entered Earth's atmosphere in an uncontrolled tumble. Debris scattered across a field in Poland, a nightmare scenario for a company that prides itself on safety and control. This marked only the 3rd time in over 300 launches that a Falcon 9 stage failed to properly deorbit. These consecutive failures have raised serious questions within NASA and among commercial customers who rely on Falcon 9's proven reliability for billion-dollar payloads and, critically, human spaceflight. The numbers tell a compelling story. In 2023, Falcon 9 flew 96 times, already a record for any rocket system. In 2024, they pushed to 138 launches. For 2025, Musk has set an almost unfathomable target: over 180 launches. This schedule requires a launch every 48 hours on average, each booster flying approximately 7 to 8 times per year, refurbishment teams working around the clock, perfect weather conditions at unprecedented frequency. A former SpaceX executive told us, "The company has always operated on Elon time, aggressive schedules that push teams to achieve the impossible. Sometimes you break barriers, sometimes you break rockets." Internal documents suggest that inspection protocols have been streamlined to accommodate the accelerated schedule. Where boosters once underwent 72-hour minimum inspection periods, some are now cleared in as little as 36 hours, provided they meet certain flight history criteria. As Falcon 9 struggles under the weight of its demanding schedule, SpaceX faces a parallel challenge with Starship. The next-generation vehicle has consumed enormous resources, both financial and human, with mixed results. While early 2025 saw a successful flight, subsequent tests have revealed persistent issues with the thermal protection system and the complex stage separation mechanism. NASA officials have privately expressed concern about the timeline for their Artemis lunar landing program, which depends on a functional Starship variant. This creates a dangerous feedback loop. As Starship demands more attention, resources are pulled from Falcon 9 operations. Yet without Falcon 9's reliable revenue stream, funding for Starship development becomes more precarious. Several high-level engineers have reportedly been reassigned from Falcon operations to troubleshoot Starship problems, potentially contributing to oversight gaps in the established program. Despite these challenges, it would be premature to count SpaceX out. The company has consistently demonstrated an ability to learn from failures and implement corrections with remarkable speed. After the March 2nd incident, SpaceX grounded the fleet for just 12 days, much shorter than traditional aerospace companies would require, before resuming launches with modified inspection protocols focusing specifically on fuel system integrity. The question isn't whether SpaceX can recover from these setbacks, but whether they'll recognize the need to recalibrate their ambitions before a more catastrophic failure occurs. Industry analysts suggest that a more sustainable cadence might be 120 to 130 launches annually, still far exceeding any competitor, but providing breathing room for proper inspection and maintenance. What's certain is that 2025 has become a critical inflection point for SpaceX. The coming months will determine whether the company can maintain its delicate balance between revolutionary ambition and operational discipline, a balance that has made it the most successful private space company in history. Despite these challenges, the story of SpaceX in 2025 is far from written. History shows us that Elon Musk companies often face their darkest moments right before their greatest breakthroughs. What we're witnessing may be the necessary growing pains of a company transforming from a disruptive startup to the backbone of global space infrastructure. The coming months will be critical. SpaceX must find the delicate balance between maintaining Falcon 9's reliability while advancing Starship's development. Their success or failure will impact everything from satellite internet access to NASA's lunar ambitions, and ultimately, humanity's path to becoming multi-planetary. One thing remains certain: SpaceX has consistently turned what critics called impossible into routine. Whether they can overcome these current challenges will define not just the company's future, but possibly the timeline for human exploration beyond Earth. What do you think? Is SpaceX pushing too hard too fast? Or are these setbacks simply part of the innovation process? Share your thoughts in the comments below. While Starship stands tall as the world's most ambitious rocket, the path to making it operational remains shrouded in challenges that few understand. At a towering 121 meters, when fully stacked and designed to generate an unprecedented 7,600 metric tons of thrust, this engineering marvel isn't just pushing boundaries, it's redefining them entirely. But here's what most headlines don't tell you: Starship is nowhere near ready for operational missions. Years of development still lie ahead before this Titan will reliably carry humans or payloads into the cosmos. Unlike previous rocket programs, SpaceX has no blueprint to follow, no existing model to reference. Every advancement comes through painstaking trial and error in the unforgiving environments of the upper atmosphere and space. The recent Flight 8 failure perfectly illustrates this reality. What started as a promising launch ended with the vehicle spinning out of control before ultimately exploding. A dramatic reminder of the immense challenges still facing the Starship program. These persistent issues have forced SpaceX into making difficult decisions about the current version of Starship, decisions that might even lead to its complete abandonment. In today's deep dive, we're examining exactly what went wrong during Flight 8, what these failures mean for Starship's future, and why SpaceX might be on the verge of unveiling an entirely new version of their interplanetary spacecraft. Welcome to Elon Musk 24 Hours, where we bring you the latest developments in the world of SpaceX and beyond. Let's dive right in. SpaceX's approach to rocket development has always been revolutionary, but with Starship, they've taken innovation to unprecedented heights. About a year ago, facing the immense complexity of building humanity's most ambitious spacecraft, SpaceX made a strategic pivot. Instead of making endless incremental adjustments, they introduced a structured versioning system, officially designating their progress as Starship 5.1, V2, and V3.